right, so next up we have Chunting Zhou from research at Meta AI. Very excited for this talk. We will put her on stage. Hello, how are you?
Hi, thank you.
Yep, here are your slides. Take it away.
Okay, cool. So I'll just start it. Okay. So thanks everyone for coming to the talk. I'm Chunting from Meta AI, and I'm very excited to share what we have learned from LIMA with you. So in this talk, I will try to answer 3 research questions. So first, do we need large amount of annotated data to train a competent chatbot? The second question is, if so, what are the critical access when we create the annotated dataset? So the third question is, how well can a model train with a small number of annotated data generalized to new tasks? As we know, large language models are pre-trained on trillions of tokens, and we propose a superficial alignment hypothesis, such that a model's knowledge and capabilities are learned almost entirely during pre-training, while alignment teaches it which sub-distribution formats should be used when interacting with users. So in the alignment stage, we should fit the model with the right format of fine-tuning data that teaches the model to act as an AI assistant. So with this hypothesis, one conjectured that one could sufficiently tune a pre-trained language model with a rather small set of examples. So what are the critical access when creating the annotated data? We found that ensuring high quality and high diversity in the training data are the keys to success. LIMA is trained on 1,000 carefully curated examples with no model distillation data from existing chatbot models and with minor human annotations of 200 examples. So let's take a look at what composes these 1,000 examples. We have 200 examples from the stack exchange sets and 200 from the other sides of stack exchange. And we have 200 WikiHow examples. We have 150 push-shift subreddit dataset of the writing prompts. And we have 50 NLP examples from natural instructions. And we have 200 authored examples from our co-authors. So to control quality, for the public dataset listed above, we remove the artifacts in the community data. For example, in Stack Exchange, the user might refer to the answers from other posts, and we eliminated such answers because we don't want them to appear in the training data, in the chatbot response. And we select data with higher user ratings if the upvotes, if any. For the in-house author data, we set a uniform tone, and our co-authors follow the same format of a helpful AI assistant when writing the examples. So many examples start with an acknowledgement of the question, and then the actual answer, and finally a short conclusion of the answer. So to control diversity, for the public dataset, we use also the public community websites usually contains a variety of topics and domains, and we sample data with a repeated distribution to rebalance different domains to increase the domain diversity. And for our in-house author data, we pay extra attention to the task diversity to cover more user scenarios. For example, creating a trip plan or conjecture on alternative history. So we create a test set with 300 prompts with diverse topics and tasks. So LIMA performs pretty well compared to some top chatbot models. So one observation that is very interesting is in control setting, when we scale up the number of examples from stack exchange data by ensuring the same quality, we don't see any improvements in the generation quality because more stack exchange data don't bring more task diversity and improved quality in the training data. And this generation quality is measured by OpenAI model with our Likert score. So finally, how well can a model train with a small number of annotated data generalized to new tasks? I want to share some fascinating generalization ability of fine-tuning with a handful of examples. First, by adding just 30 curated dialogue examples, we found LIMA has been greatly improved in the dialogue conversations. And feel free to check our examples in the archive paper. Second, by adding just 6 format constraint examples, we find that the model can generalize to test examples from other domains. And can generate a long-form, highly structured response following user interactions, following user instructions. So one example out of these 6 training examples is review a paper from the following 4 aspects: summary, strengths, weaknesses, and potentials. And for a test example, here is a prompt: create a marketing plan with the following elements: marketing goals and objectives, define target audience, research marketing tactics, plan marketing tactics, and develop your timeline and budget. And here is the example, the output from LIMA for the prompt we just saw. So it can create a very good marketing plan that including all of the elements the user specified. So to summarize the 3 research questions in the beginning, so do we need large amounts of annotated data to train a competent chatbot? The answer is no from the observations of LIMA. And the second question is, what are the critical axes when creating the annotated data? What we found is the quality and diversity, including the domain and the task diversity of the annotated data. So the third question is, how well can model train with a small number of annotated data generalized to new tasks? We observed that after seeing a few annotated examples, the model can generalize pretty well to relevant tasks. So in the end, I'd like to point some limitations and open questions when we develop LIMA. First, we see that LIMA is still weak in coding and math, as with many other recent chatbots. One reason is that we are not building upon a very strong foundation model that has seen sufficient coding and math pre-training examples. And the other reason is that LIMA data doesn't have many well-aligned coding and math examples. So one open question here is, what is the most effective data format of learning code and math and some other reasoning intensive tasks? So second, most of the training examples in LIMA are from the public datasets, and this is definitely not the best one-shot examples. So one question worth investigating is that how do we automatically and systematically discover new and diverse scenarios and create a better version of fine-tuning dataset, no matter, even in a lifelong continuous learning setting when the model has been deployed in the wild. So it's interesting. It's also interesting to do an apple-by-apple comparison between PPO and SFT in terms of the sample and the annotation efficiency. So last but not least, evaluation is hard, especially assessing the truthfulness and the truthfulness of domain-specific questions without expert annotators. And this will be a constant issue as large language models become more and more stronger. Okay, so this is the end of my talk. Thank you, everyone.
Awesome. Thank you so much. That was so insightful and definitely surprised me in a couple directions, especially about the needing fewer annotated pieces of data than I think people would expect. I thought that was really interesting.
Thank you, Lily.
Awesome. All right. Well, please drop in the chat any links you think would be helpful for our attendees to have. And thank you so much. This was really wonderful.
Thank you, Lily. Okay, I'll just leave.
Okay.
Right.
Yeah. We'll talk to you later. Bye.